Hello friends, let us continue with two more problems on delta modulation. The first problem is as follows. Determine the output signal to quantization noise ratio SQNR in a delta modulation system for a 1 kHz sinusoid sampled at 32 kHz without slope overload and followed by a 4 kHz post-reconstruction filter. So the data that is given is the signal frequency FM equal to 1 kilohertz. The sampling rate Fs is given to be 32 kilohertz or 32 kilosamples per second. And the cutoff frequency of the low pass filter used as a reconstruction filter at the output is given to be 4 kilohertz. So F sub capital M equal to 4 kilohertz. Now we are supposed to compute the signal to quantization noise ratio SQNR under no slope overload condition. We already have derived the expression for it as 3 FSQ upon 8 pi square Fm square F sub capital M. We just need to plug in all these values and it evaluates to 311.3, and in decibels it can be written as 10 log of 311.3 to the base 10, and it works out to be 24.9 dB. So this is the maximum signal to quantization noise ratio under no slope overload condition at the output of the reconstruction filter. Let us go for another problem. A delta modulation system is designed to operate at 3 times the Nyquist rate for a signal with a 3 kHz bandwidth. The quantization step size is 250 millivolts. There are two parts of the problem. In the first part, they ask to determine the maximum amplitude of a 1 kHz input sinusoid for which the delta modulator does not show slope overload. So let us write what is given. So the sampling rate Fs is equal to 3 times the Nyquist rate for a signal with 3 kHz bandwidth. So a signal with 3 kHz bandwidth will have a Nyquist rate of 2 times 3 kHz. This is the Nyquist rate for a 3 kHz signal, and 3 times of it is the sampling rate. So it is 18 kilohertz or 18,000 samples per second is the sampling rate. So note that 2 into 3 kilohertz is the Nyquist rate for a 3 kilohertz signal. Also given is the step size delta equal to 250 millivolts. And now look at the first part of the problem. The signal frequency is given to be 1 kilohertz. So Fm is equal to 1 kilohertz. And we are required to compute the maximum amplitude that does not result in slope overload. So we know that the maximum amplitude which does not result in slope overload is equal to delta by 2 pi into Fs by Fm. Now all these values are given. Delta is 250 into 10 to the power minus 3 volts. Fs is 18 into 10 to the power 3 hertz. And Fm is 1 into 10 to the power 3 hertz. We just plug in all these values and it works out to be 716.2 into 10 to the power minus 3 volts or 716.2 millivolts. volts after plugging in all the values. Let us now look at the second part. Determine the post-filtered output SQNR for the signal of part 1. Now in this problem, the cutoff frequency of the reconstruction filter is not given, and we know that if the cutoff frequency Fm, F sub capital M, is not given, we can consider it to be equal to F sub small m. Going by that, we can write SQNR at the output equal to 3 by 8 pi square into Fs upon Fm whole cube, assuming the cutoff frequency of the reconstruction filter, assuming cutoff frequency of output low pass filter F capital M equal to F small m. And now after plugging in the values, 3 upon 8 pi square into Fs is 18,000 samples per second. So 18 into 10 to the power 3 upon Fm is 1 kilohertz. So 1 into 10 to the power 3 is whole cube, and it results in 221.6, which is approximately 23.5 dBs. To convert a power ratio or SNR in dB, take log of that quantity to the base 10 and multiply that result with 10, you get the dB value. So that's all. I hope these problems are clear to you. Thank you.